green hydrogen production is set to increase rapidly, posing a significant challenge for the industry. Large-scale industrial water electrolysis plants use hydrogen and oxygen within the same equipment, separated by a membrane or diaphragm. Ensuring process safety is essential. In this post, I've summarized the safety study required for your green hydrogen project. HAZID. HAZID, or Hazard Identification Study, is a qualitative technique for identifying a process's main hazards. It involves using a block diagram or process flow diagram, which is used in the early stages of the design process. HAZOP. HAZOP, or Hazard and Operability Analysis, is a method to identify process hazards by analyzing deviations from normal conditions at the P and ID level. It focuses on equipment function loss and human error. Key elements of HAZOP sessions are deviation, cause of the deviation, consequence of the deviation, and installed safeguards. The bow tie method visually presents hazard scenarios, including the chain of events and barriers to prevent or mitigate scenarios. It is useful for internal and external communication of scenarios. A risk matrix is used to assess the tolerability of a scenario based on the frequency and severity of undesired events. Likelihood is measured in frequencies per year, while consequences are defined by HSE impact and economic losses. The risk matrix determines the risk level. Quantitative risk analysis, or QRA, is a method for calculating safety contours by considering the combination of fatalities and frequency. It involves determining the frequency of fatalities using tools like fault tree analysis, often referred to as FTA, and event tree analysis, or ETA. The consequence itself is determined using other tools, and all barriers that have an effect reduce the evaluated risk. Level of protection analysis, commonly known as LOPA, is where a small team further analyzes a subset of the most hazardous scenarios identified during a HAZOP. They assess the frequency and severity of the consequence. The basic principle of LOPA is that every safeguard may fail, so the consequence of the non-protected scenario cannot be eliminated. Safety integrity level, or SIL. Assessments are used to assign risk deduction factors to instrumental safeguards. The requirements for safety instrumented systems are given in IEC 61508 and 61511. 4 SIL levels are specified, with SIL 4 having a risk deduction factor of 10,000 to 100,000 and SIL 1 having a factor of 10 to 100. Failure mode and effect analysis, or FMEA, focuses on equipment part failure and frequency to determine maintenance strategies. The accuracy of risk assessment depends on data quality.